My name is Kimberly Faldetta, and we're in Building 10 of the NIH. I research HIV, and specifically we look at the kinds of immune systems that people have that get HIV and what kind of opportunistic infections they get. When I was really young, I used to read Greek myths with my dad, and from there it kind of evolved into learning about the stars and then building telescopes and asking questions about physics. From the point of astronomy, I kind of opened up to other branches of science, including medicine. And I think I first got excited about medicine and tropical diseases, which is what I'm interested in now, when I was in college studying a parasitology course on life cycles of parasites. And for some reason that got me really excited. I'm from Massachusetts, so I grew up in rural Sherburne, which is about 40 minutes outside of Boston. And then after I graduated from high school, I went to McGill University, which is in Montreal in Canada. And there I studied the ecological determinants of health, and I kind of got into science from that angle, looking at the environment and the ways the environment impacts our health. After that, I went to Peru to do some malaria research. I finished my 3rd year of medical school, and then I came here to the NIH. I do a lot of exercise. I was a field hockey player in college. I recently did a Ragnar, which is a 24-hour relay race. So there were 12 of us, stayed awake for 24 hours and ran 17 miles in 3 legs. What I'm doing is looking at a specific opportunistic infection called Mycobacterium avium complex, or MAC, that infects patients who have HIV. And what we're looking at is the immune system's reaction to the pathogen, and we're trying to figure out what kind of immune cells are really the most active in the infection. And once we figure that out, we can kind of work to come up with a treatment that's more effective than the current treatment. When I come in, I usually do a lot of pipetting, which is kind of moving fluid from one container to another. It's not very glamorous. But we also collect samples from HIV patients that are seen here in the clinical center. And we process those samples and we kind of distill them down to just their immune cells. And then we take those immune cells and we stimulate them with different bacteria or viruses. And then we look at the kinds of things that those immune cells produce. So tons of people all the time. You're always interacting with people. Well, we hope that the syndrome that a lot of these HIV patients have, which is called immune reconstitution inflammatory syndrome, it's kind of a mouthful, but we call it IRIS. We hope that that's kind of going to be a thing of the past where we have a more targeted treatment. Right now the treatment is to kind of dampen down the immune system entirely with corticosteroids, but that's not really a very specific treatment for a person, especially a person who already has HIV, so they're immunosuppressed. We don't want to dampen their immune system a lot more. So we hope that by studying this syndrome, we can kind of find a different way, a different mechanism to dampen the inflammation that's more specific to IRIS. I think my advice to young people or anyone who wants to have a career in science would be really tenacious about looking for opportunities, and don't ever give up, because there's a lot that's out there. But you know, some people are busy, some people can't return your email, but just keep plugging at it and contact as many people as you can, and really try, because your enthusiasm and if you just don't give up, then you'll finally make some headway with getting a position or getting into science.